Now we're going to look at how to solve problems using the sine law. What is the sine law, you ask? The sine law can be used to solve a triangle that is not a right angle triangle, but rather either an acute or an obtuse angled triangle. Here would be an example. For any triangle ABC, the sine law states sine A over A is equal to sine B over B, which is equal to sine C over C. It can also be inverted. A over sine A is equal to B over sine B, which is equal to C over sine C. A side length can be determined if the corresponding angle and one other side angle pair are known. This sets up a ratio. An angle measure can be determined if the corresponding opposite side and one other side angle pair is known. Again, using ratios. If the lengths of two sides and the measure of one angle are known, this is an ambiguous case. We're not sure. Let's take a look at the ambiguous case. Given triangle ABC with known side lengths A and B and known angle A, if A is less than B times sine A, no triangle is possible. These measurements don't work. This is what it could look like. Another situation, if we have triangle ABC with known side lengths A and B and known angle A, if A is equal to B times sine A, then one right angle triangle is possible. And of course, it would look like this. And the third situation, in a given triangle ABC with known side lengths A and B and known angle A, if A is greater than B times sine A, then two triangles are possible. This is an ambiguous case. You need to determine which triangle you would use. We will learn this in this particular part of the course. And your diagram could look like this. Here is a sample question. Determine the length of F to one decimal place in this given diagram. What do we know? We have angle E, 118 degrees, side E, 19.5 meters, side D, 12.6 meters, and we're trying to find F. Now, two side lengths and one angle measure are known. Let's check for the ambiguous case. Side E is opposite the known angle. Since E is greater than D, the side lengths, only one triangle is possible. This is not an ambiguous case. So we can work now through the solution. Determine angle D would be the first thing you would need to do. Sine D over little d, the length of the side, is equal to side angle E over E. Substitute in the values. Sine D over 12.6 equals sine 118 degrees. Divide by 19.5. multiply, and you will get sine D is equal to 12.6 times the sine of 118 degrees divided by 19.5. Using your calculator and the inverse sine function, you will get angle D to be equal to 34.7864, and so on. Let's round it off to approximately 34.8 degrees. Now, we are ready for step 2. And in step 2, we're going to determine angle F. Keep in mind the angles in a triangle add up to 180 degrees. So we would know that angle F is 180 degrees minus the sum of the other two angles, 118 degrees plus 34.8 degrees. This will give us a measure of 27.2 degrees. And now we're in a position to find the value for F, again using the sine law. F over sine F equals E divided by sine E. F over sine 27.2 degrees equals 19.5 divided by the sine of 118 degrees. Cross multiply, F equals 19.5 times the sine of 27.2 degrees divided by the sine of 118 degrees is equal to 10.095, and so on. Rounding it off, we get approximately 10.1. Does that seem reasonable? State the conclusion. The length of side F is approximately 10.1 meters. Now you are ready to complete Project 1, Task 2.